It seems that gold truly doesn't belong on the surface of the ground, but it is often found that way. So how do the scientists explain something which belongs underground so often be found on top? But potato-sized nuggets were found all throughout this area and in the gullies. Obviously, many of the mountains we see are pushed up by underground forces, and some areas are eroded over time, which allows the heavier materials to gather in the lower sections of the gullies. Actually, that's a runoff from a gully, but huge gold nuggets are found right around this area. Which is why you find rocks on top of the ground, but are most often found deeper underground, and why topsoil is mostly found on top of them. That's my homemade underwater metal detector. It's a coil for testing, a pile of electronic pieces, circuit board, both-sided circuit board, and soldering iron. You can see they operate on a fine and very precise line, and are either on or they're off. This part here, this is the guy that's doing most of the work and pumping most of the power into the coil. Now this guy here actually supplies all the power temporarily. These can get so hot that they burn out, so you need an aluminium heat sink. The whole engine or circuit is directed by these little fellas here, the integrated circuits, or ICs as they are known in the computer terms. Here I am insulating the wires with some heat shrink, and I'm going to conduct an experiment with some salt water in a bucket. You can see the light flashing on the side of the bucket. Alright, we'll just start off by wrapping that around there, leaving a little bit of overhang. We can get some tape around this section here. We'll just do that 22 times, and we have an elliptical shape. Back in the days when the huge gold nuggets were found in Victoria, most people were so impressed with the sheer size and number found in the relatively small gullies that they thought they actually grew on the surface of the earth. When you consider on average 4 to 8 gold nuggets weighing over 50 ounces each, and hundreds of smaller gold nuggets were often found clean and very pure with no quartz in them at all. It is a well-known fact that gold originates in quartz reefs, and pieces over half an ounce are actually quite rare in the reefs themselves. I wonder if that's a mine shaft. The only way to find out is to jump in. There's no way I'm jumping in. Good luck. Now, well, that sort of tells me that this could be the outcrop. The old timers found it. This is the quartz outcrop containing gold. We want to make sure we get some tape around that, because it is spring loaded. As soon as you take it off, it'll make a mess, and we don't want that. Now we have our detector coil. All we got to do now is just scrape the insulation off the tips. This will help protect the coil from unwanted interferences. They call it a Faraday shield. Alright, leaving a gap at the ends there. Just twist that round. Make sure we join them up. However, the search coil has to be completely redesigned if it's going to work in the goldfields. Here you're asking a detector to recognize a metallic object through earth, which is not only heavily laden with conductive materials like metal, but fluctuates wildly on every pass. In other words, the detector has to penetrate the equivalent to a huge mass of iron filings while having the power to concentrate energy on a not so very conductive material like gold, and then pick up this slight energy increase without interference from the wildly fluctuating, heavily impregnated ground. Now, I've got some highly mineralized soil just there. I'm just going to put that on top of the coil, and we'll see what happens. It's going to react badly to it. It's settled down. The point is that the large pieces found in these areas had to have come from the reefs. Anyhow, the theory was that the chemicals in the dirt would act just like an electroplating process we know of today in a laboratory or factory. The only thing that was missing in the theory was the electrical current to carry the particles in the ground to coat the gold pieces, but they eventually explained the whole process with a large concentration of lightning bolt strikes which struck the trees and earth over the millions of years. And the evidence they obtained certainly well supported this idea and almost became the accepted theory as how the Victorian goldfields had so many large gold nuggets, and in such small pockets of ground the earth was said to be rich in gold. Alright, we're going to make it extra mineralized by putting a few of these on there. Okay, I'll just show you what that looks like. It's reacting to the camera. What do you think will happen if we place on top of the coil a large sheet of aluminium foil? Will it overload the detector circuit, or will the detector coil simply penetrate through the aluminium? One possible answer is that it is simply not penetrating the aluminium foil. But if that's true, look what happens when we wrap the entire coil in aluminium foil. On the less than a gram gold nugget, it actually appears to become more sensitive and more stable. Right, got to go over the whole thing with some silicone. Okay, what I've done here is I've coated that with silicone and give it a good 3 layers of a good strong tape over the top of it. Now you've got to keep these two wires separate, solder them and make sure they're not touching, and completely seal this off with silicone. As you can see, I've marked it all out. So it's a nice shape, maintain the strength around here. Zip tied the coil on, that's all waterproof really well so no water can get in. Got a bit of a taper on that so it cuts through the sand, and also a bit of grip. So when you put your feet you can shovel it into the ground well. It's got this bum bag that just straps around your waist. Just grab this, put it inside, hook up your coil, switch it on, away you go. Nothing. Not even if I get really close. Kind of in there. But I'm going to just change something and show you an anomaly I've found. Right, watch what happens. Same ring. Why is it picking it up now? Good depth too. Right. The difference is, see that little cut? When I squeeze it, it closes the loop and the detector picks it up. Look at the size of those holes. But the interesting thing here is that these gullies had the larger gold pieces in the narrower, once upper section of the gully, and they were often less than 2 feet deep. And a new generation of gold detector can quite easily find these larger pieces even at this depth. But the old timers often didn't follow the drifts down to the once lower parts because the gold pieces are smaller and more spread out. It's commonly reported that the old timers would often be plagued by mosquitoes in these areas, especially because they often contain water, and the old timers would abandon the gold field for that very reason. If you follow the direction from these mine shafts to the gullies where the old timers once found the gold pieces, you can be reasonably assured of success. And once you find one, there is a good chance that you will find many others around. And the odd large pieces. I'll leave it as it is. It's not a closed loop. Tell you what, I don't know if this is, but that looks like. But the directions straight to the gold-rich gullies are often very confusing, as there are many gullies around and the right direction may be up, over, or even on the side of a hill, and may even have a layer of topsoil on the surface. Now that kind of quartzy ground there is pretty good. It's mineralized. What you got to stay away from is this type of earth here. It's very soft, very flowery. It's only got the light pieces of silver foil, bits of iron, bits of rubbish. But here is an important tip. Take note of the trees. trees adapt to the changing ground conditions very slowly. Dead or dying trees is a dead giveaway as to where the gold is, because the lower sections were often ancient lakes or water saturated areas where the trees died young because of wet feet or too much heavy mineralization to react.
An 18-carat ring maybe with a diamond? Holy shit! You little beauty! I wonder if we got any more. Check it out. I'm gonna put this in my pocket. Coin. Coins. More coins. Come on. Hat. A 9-carat. We got a 9-carat ring. Okay, let's see what else we got. I'll put all the stuff here. That's probably silver or 9-carat. Like it. Bottle, hang on. Another one. That's probably silver. So what we got? We got one 18-carat, one silver, one 9-carat, a few coins, a lot of bottle tops. I know we had a lot of little sinkers, but they all fell through the holes. So that's only designed just to catch the rings. The small rings can't get through that, but the little sinkers can get through. 5-cent pieces can't get through. So I'm really happy with that. That's pretty good going. That's a nice fat diamond on that. So, paid off, guys. Today paid off. All that hard work, about 4 or 5 hours hard work, it's paid off with a beautiful that's probably a platinum setting in that too, and a diamond ring. Good stuff.